and welcome to our last video, woohoo, of the semester. So this is in Blackboard, either print or take notes. It's a pretty short section. It's understanding multiplication and division of fractions or rational numbers. So the two that we're going to be devoted to are repeated addition and what's called a rectangular array, and Engaged New York loves the rectangular array problems for multiplication. So just convince yourself, right, that part A is a multiplication problem. So Julio runs 4 times a week. His route is 2¼ miles long. How many miles does he run each week? So he runs 4 times a week. So this is what is called repeated addition to solve multiplication. So that's pretty self-explanatory. For part B, which is what we're really going to concentrate heavily on, is what's called the array model, or what Engaged New York likes to call the area model for multiplication. So it says a group of investors purchased a rectangular parcel of land that is 3¼ miles long. So if this is a full mile, this is where the 3¼ would fall, and 2/3 of a mile wide. So if this is a full mile, this is where the 2/3 would be. It says how many square miles did they have? Okay, so if you mark this at 1 or 3/4, remember how I said you have to divide everything up into a quarter? And if you divide this up into thirds, everything gets divided up into thirds. And so you can see where I've marked it. So let's look at the whole. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The whole's been divided up into 12 parts, and you want 6 of them. So your answer to this would be 1/2 of a square mile, if we simplified it. It's very, very different, but very, very cool. So let me just remind you quickly about the commutative and associative and multiplicative identity properties for multiplication. So commutative means the order does not matter, right? 3 times 5 is the same as 5 times 3. Associative property says if you have more than one factor, it doesn't matter where you start to multiply. You could say A times B first, you could say B times C first, or you could even go A times C first. And the multiplicative identity is saying that anything times 1 gets you A, what you started with. Just a little quick review. All right, so let's look at the area model. So Engaged New York loves their pans of brownies. I think all the questions deal with pans of brownies for these 5th graders. So this is 5th grade, right? Module 4, lesson 13. So if you went into the computer and said Engaged New York, grade 5, lesson 4, or I'm sorry, module 4, lesson 13, this is what would come up. So it says solve, draw an area model to show your thinking. So the area model is this picture. Then write a multiplication sentence, and says the first one's been done for you. So let's figure out what they're doing, and then we'll check out these two. So it says 1/2 of a quarter of a pan of brownies. So we're going to start off with 1/4 of a pan of brownies. So we're going to draw our pan of brownies, and we want 1/4. So they drew their quarters like strips. Okay, so here's 1/4, and we want to take 1/2. But if we take 1/2 of that strip, we've got to take 1/2 of everything. Okay, so if we draw these out in color, you ready? So here's my quarter that I started off with, right? There's my quarter that I started off with, and then I took 1/2 of that. So my answer is 1/2 of the yellow. So let's look at my full pan of brownies. Ready? So I divided up my brownies into 8 pieces, and my solution is 1 of those. So 1/2 times 1/4 is 1/8, because of means multiply. All right, let's try this one. So half of a third of a pan of brownies. All right. So we're going to start off by drawing a pan of brownies, and we want a third of them. So I'm going to draw my third in yellow. So here's my 1/3 of my pan of brownies. And then we want half of that. So right there is my answer. But if you take half of this third, you got to take half of everything. All right? So there's my answer right there in the checkered. So if you look at your pan of brownies, how many brownies was the pan divided up into? And how many am I looking at for my answer? So they would say 1/2 times 1/3 equals 1/6. What do you think? You guys getting it? Does that make some sense? So here, let's try this one. It says 1/4 of a third of a pan of brownies. Okay. So let's start with a third of a pan of brownies. So right here's my third. I took up the pan and I divided it up into thirds. And now I want 1/4 of that. So let's divide this up into fourths. Okay, and then I want 1/4. Now look, if I divide this up into fourths, everything needs to be divided up into fourths. Alright, so my answer is this checkered. Now let's take a step back. Look, how many pieces did I divide my brownies up into? Looks like 12, and I want one of those. So 1/4 times 1/3 equals 1/12. You guys doing okay? All right. So you can look at, I gave you a print of the answer key. Okay, I gave you a print of the answer key. And let's modify this. If they said we want 3/4 of a third of a pan of brownies. So if they said I want 3/4, then I would shade in 3 of these, right? 3/4 of these. And so my answer would have been 3 out of 12. We doing okay? All right, so let's play with a little bit bigger problems. You ready? So they do this concept using these tape measures or pans of brownies when they're multiplying a proper fraction times a mixed number. All right, so we're going to take it one step further. So this is really saying 3/4 of 2 1/2. So I have 2 1/2 pans of brownies that I'm starting off with. So 1, 2 1/2. Okay, now look, I'm going to outline this in yellow. So this is what I'm starting off with, 2 1/2 pans of brownies. Okay, but, and I'm going to mark where in green where each pan is. There's 1 pan. Here's 2 pans. But look, since I divided that third one into halves, everything gets divided into halves. Each pan of brownies got to get divided into halves. So I don't want this part. So this part is not included. Only in the yellow. So that's my 2 1/2 pans of brownies. We okay? And then I want 3/4 of that. So we have to divide everything into 3/4. I'm just going to stop it here because that's not part of my answer. I don't want that. So there's 1. Okay, there we go. So now out of this I want 3/4. So this is 1/4 of my 2 1/2 pans. Here's 2/4 of my 2 1/2 pans, and here's 3/4 of my 2 1/2 pans. Okay, so now let's look at 1 pan of brownies. So here's 1 pan right here. how many pieces has one whole been divided up into? Do you guys see it's been divided up into 8 pieces? All right. So how many of these 8s have we colored in? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's my solution, 15 over 8. Or the cool thing is, you could also go right into the mixed number. So the students know that 8 pieces makes a whole pan. 1, 2, 3, 4, 5, 6, 7, 8. There's one full pan. 1, 2, 3, 4, 5, 6, 7. And 7/8 left. What? That's cool, right? I think that's pretty cool. And if you want to simplify the fraction, you can. I mean, we can't simplify that one, but in the future, if we want to simplify, we can, but for right now, we're not going to. All right? So I'll talk about the definition in a minute. Let's just practice a couple more of these. All right? Let's practice. Okay. So this is saying I have 2/3 of 1 3/4 pan of brownies. So let's mark our pans. So here's 1 pan of brownie, 2 pans of brownie, 3 pans of brownie, but we don't need this one at all. And then we want 1 full one and 3/4 of this one. Okay. But if I divide this one into quarters, I have to divide this one into quarters as well. All right. So here, I'm going to mark in red where my pans were. So this is 1 pan right here. And here's where the second pan was, right? But we didn't want that whole second pan, okay? So in yellow, I'm going to define what I want. So I want 1 full pan and just 3/4 of the second pan. So what's in yellow is what I'm starting off with. So I can get rid of this stuff. I don't want this. This is not part of my answer. So I'm just going to get rid of that. If you want to fold the paper, to have kids cut it out, that's nothing. That's not anything I need. And yellow is what I'm starting off with. And we want to divide that up into 2/3. And so, not drawn to scale, but we want 2/3. So there's 1/3, 2/3. Okay. So there's my answer. Like this right here in yellow is my answer. So now you have to find your original pan of brownies. Do you see there's 1 pan right there? So how many pieces has 1 pan been divided up into? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1 pan of brownies been divided up into 12 pieces. So each piece is worth a 12th. And how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 14 over 12. Or they know 12 pieces makes a whole. So 2, 4, 6, 8, 10, 12. There's 1 and 2/12 left over. I mean, you could call this 1 1/6 if you want, or we could call this 7 over 6 if you want, but these are good looking answers right now. I'd prefer this right now over a simplified version, because when we do the multiplication rule, you're going to see how this works out. I mean, isn't this kind of cool? I mean, we're not multiplying at all. To multiply this, it's not that easy. I was taught you had to make this into an improper fraction, then you multiply through, and then you change it back to a mixed number. But we'll get to that in a second. Okay, last one. You ready? Let's try this guy. So I want 1/3 of 2 1/3 pans of brownie. All right, so let's make our, in red, I'm going to make my pans. So here's where 1 pan of brownies is, and here's where 2 pans of brownies, right? And I only want 1/3 of that second 1, 2, and I only want 1/3 of that last pan of brownies. But if I divide this up into thirds, everything gets divided up into thirds. Okay, so in yellow, I'm going to outline what I want. I want 1, 2 1/3 pan of brownies. Because the red defines 1 pan, 2 pans, and 1/3. So I don't want any of this. None of this is part of my solution. Yuck. Get rid of that. We cut that right out. So there's my 2 1/3. And now I want 1/3 of that as my answer. So I want 1/3 of these 2 1/3 pans of brownies. There we go. Oh, one more. All the way over. 1/3 of it. All right, so here's the tricky part. Take a step back and look at your pan of brownies. So 1 pan goes where I'm circling. So 1 pan's been divided up into 9 pieces. So out of the 9 pieces, how many pieces do we have? 1, 2, 3, 4, 5, 6, 7. We have 7 over 9 pieces of brownies. So let's go over how you guys learned it and how I learned it. I was taught that if you multiply fractions, you multiply numerator times numerator, denominator times denominator, and then you simplify it. So let's check that. Now, in order to do this, I mean, we're going to look at the distributive property in a minute, but for old time's sake, you would have had to said 3/4 times, and if we put that into an improper fraction, that would have been 5/2. And you would have said numerator times numerator, denominator times denominator, and then we always had to go back to a mixed number. So how many 8s can you get out of 15? 1, and then we would have 7 8s left. Right? It's very different. This is kind of cool because it's very visual. Right? Really very, very visual. Like for this one here, let's do it. So 1/3 times, so this would have been 7/3. Numerator times numerator, denominator times denominator. Right? That's great. That's just a rule. But I think that this is cool because it's very visual for kids. And they can see the product, not just calculate it, but they can see it. All right, anyway, you have, there's a bunch of these in the homework, there's, I know, at least one on the review. Okay, so give them a try. Let me know if you have any questions on it. The other piece that's in Engaged New York that I thought was interesting was using the distributive property. And I know I've said this before, that Engaged New York loves the distributive property. So what they're doing is they're using the distributive property to multiply a whole number by a mixed number. So let's look at what they're doing. So they expand it, because they love expanded form. They expand the fraction away from its whole number, and then they take that 3 and go 3 times 6, that's easy, 18, and then they say 3 of these 4/5. So 3 4/5 would be 12 of these fifths. And then they go from that that improper fraction to a mixed number. And they said the step has been eliminated. They didn't show the step on how to do it, but this is what they would have done. They said that they eliminated it. They didn't show the step. So you would have gotten 10 out of 12 pieces. You can get 2 groups of 5. That would be 10/5. 2/5 left, and they cross that out and call that a 2. So that's where they said they were missing the step. Okay, and then they combine these, 18 and 2/5. Very different. Okay, so let's try one. You ready? So we have 5 times 4 plus 1/6. So that's going to be 5 times 4 plus 5 times 1/6. So this is going to be 20. And if we have 5 of these 1/6, that will be 5/6. So the answer is 20 and 5/6. kind of cool, right? Here, why don't you try this one? Turn off the video and try that one, and then come back on and we'll look at it together. Okay? All right, let's see how you did. So we'll have 6 times 2 plus 3/5. So we'll say 6 times 2 plus 6 times 3/5. So this will be 12. So if we have 6 of these 3/5, that will be 18/5. And then let's convert that to a mixed number. So Engage New York tells the kids to number bond it. So we've got 5/5, 10/5, 15/5. So I can get a 15/5 out of there. And then I'll have 3/5 left over. See the 18? And then this would be 3. So they would say that this is 12 plus 3 3/5, or 15 3/5. Okay? Just different. I thought that was kind of a cool method. Okay, so that's all you need to know for multiplication of fractions. You need to know the Brownie method. You need to know this method, where you'll have a proper fraction times a mixed number, and then you need to know the distributive. And you can, if you look at the review, which I'll post on, I'll post tomorrow. I just have to make the key, so I'll post those by tomorrow night, and then you can look that over and ask me questions between Wednesday and when the test is on Tuesday. All right, the last thing, our division of rational numbers. And I found some fraction circles so I can actually show you this stuff. It says, what does 10 divided by 5 mean? So using whole numbers, you would just say, well, how many groups of 5 can be found in 10? I mean, if you want to think about it on a number line, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how many groups of 5? 1, 2, 3, 4, 5. There's one group. 1, 2, 3, 4, 5. There's 2 groups with nothing left over. So that's why the answer is 2. Same thing goes with fractions. So this would be, how many groups of 1/6 can be found in 1/2? So I found some fraction circles that we'll play with. Okay? So this is what I've been talking about with fraction circles. These are these plastic manipulatives. I don't know whose these are, what kid of mine, but I was looking in, cleaning some drawers, and I found these fraction circles. I was like, oh, sweet, I will use these. All right, so this circle's been divided into 2 equal parts. This circle has been divided up into 6 equal parts, right? So these are 1/6, and this is 1/2. So how many groups of 1/6 can be found in 1/2? Here we go. 1, 2, 3. Look at that. We just divided fractions with just using manipulatives. That's cool, right? So kids aren't intimidated by that. 3. The answer is 3. Right? So you can find 6 or 3 groups of 1/6 and 1/2. Okay, what does 3/4 divided by 1/8 mean? It means, well, how many groups of 1/8 can we find in 3/4? That's what division means. All right. So I have fraction circles for this. So here's a circle that's been divided up into 3/4, or into fourths, right? And then next to it, I'm gonna have a circle that's been divided up into 8ths. And again, this is just to get kids accustomed to what division really means, right? So let's see. Yep. That makes a whole circle. I was wondering if I had the wrong pieces. All right, so we have 4ths and 8ths. Do you see that? All right, so we want to know how many of these blue can we get out of 3/4. So this is not bad for kids to play with. So they would just line up the pieces. I mean, they don't need to know any formula for division, right? They can just play with manipulatives. So no one's intimidated by division with fractions if this is the way they're going to play with it. So it looks like you can get 2, 4, 6, 1/8 out of 3/4. We good? That's all. We're done. Now I know you know that there's a simpler way to do it. Cool. And we'll give that to you on the last page because I want to show you some more Engaged New York work. All right. Okay. So again, 5th grade. Right? We're looking at some 5th grade work. A lot of fraction with manipulatives with 5th grade. So let's do this first part and then we'll concentrate on the second part because it says draw a tape diagram, right? We've talked about tape diagrams, and a number line to solve. So you may draw the model, either this one or this one, that makes the most sense to you. Okay? Fill in the blanks. The follow, use the example to help you. All right. So this says 2 divided by 1/3. So they're doing it exactly like we're doing it, okay? Like what we just did. So the cool thing is, though, they're saying, what they're doing is they're saying, okay, so we're going to draw 2, and we're going to divide these up into thirds. So here's 1, here's 2, and we started with the 1 and divided up into 1/3. So they said there are 3/3 in a whole. So if we started off with 2, then we're going to have 6/3 in 2 wholes. Does that make sense? So if it would be the same thing. So if it said 3 divided by 1/3, well, they would say there are 3/3 in 1 whole, so 6/3 in 2 wholes. So if you started off with 3 divided by 1/3, it would just be another 3. So then there would be 9/3 in 3 wholes. Does that make sense? Do you see the pattern? All right, so here, let's practice with this technique, and then we'll look at the second technique that they gave us. So 4 divided by 1/2. All right, so they want us to draw a number line. Okay, we'll start it at 0 here. And we're going to go 1, 2, 3, 4. Okay? So we're just going to concentrate on 1 first. Okay, we're going to take this 4, and we just want to know if we just have 1 and we're dividing it into 1/2. How many 1/2s can we get out of 1? So there are 2 halves in 1. So now we're going to extend that and say, okay, now we have 2 cut in half, 3 cut in half, 4 cut in half. So how many halves are in 4 wholes? 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 halves in 4 wholes. And I really like how they're even getting these kids used to this. So this would be 1/2, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves. Isn't that cool? 7 halves, 8 halves. Isn't that neat? So they're even getting the kids kind of started accustomed to seeing that 2 is also 4 halves, 3 is the same thing as 6 halves. It looks like how this number line system works, how they're writing that out. All right, let's try it again. You ready? 2 divided by 1/4. Okay, so we got 0, 1, 2. All right. I'll just do the whole block now. So first they said, okay, well, let's just look at 1. So how many 1/4 can we get out of 1? Okay, so we can get 4/4 in a whole. So that means then we must be able to get 8/4 in 2 wholes, because we have 1 whole and 2 wholes. You getting the rhythm of it? It's not that bad, but you got to play with it. Okay, so we've got 1, 2, 3, 4, 5. Here's my tape measure. So there's 1, 2, 3, 4, 5. All right. So how many thirds can we get out of 5? Well, let's first of all, how many thirds can we get out of 1? So there are 3 thirds in 1. So then if we have 5 of these, then it should make sense that there'll be 15, right? We can get 3 thirds out of you, 3 thirds out of you, 3 thirds out of you, and 3 thirds out of you. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Are we okay with that? Does that make sense? All right. Now this method is definitely different. And this method is banking on the fact that you understand that multiplication is a way to solve division problems. All right? So I was talking to my son, and when he was talking about the time test that they used to take for division, and he said oops, let me put a 3 there. He said he never would say 63 divided by 7. He would say, what times 7 gives you 63? That's the way he said he learned this stuff. It wasn't, he never thought about it in terms of division. He always thought about these problems in terms of multiplication. So what times 7 gives you 63? It would be 9. So that's what this part is, okay? So again, we're starting off with 2 divided by 1/3 is what? All right? So remember, remember is means equals, right? So they're saying 2 is 1/3 of what? Do you see it? So there is like this. I know this looks weird, but they're saying 2 divided by 1/3, and then here's their question mark. This is my, if you want to call it an X, you can, but they're looking at it as what times 1/3 is going to give us 2. All right? So they're saying 2 is equal to 1/3 of what? So 2 equals 1/3 of some value. Okay, what we're going to call, they say, what is the whole? We're going to call this a whole. So 2 is 1/3 of a whole. So what they've done up here, I'll simulate it. You ready? So they're going to say 2, this 2 is equal to 1/3 of something. So then we need 3 of these 2 to get to what's considered the whole. So this is 1/3, this is 1/3, and this is 1/3. So this is now equal the whole. So we've got 2, 4, 6. We need 6 of these 2's to get to the whole if each of these is 1/3. It's really weird, but I understand it because it's this concept. They're teaching this as the reverse of multiplication. So 2 is equal to 1/3 of what? So 2 is 1/3 of some value. So if 2 is 1/3 of some value, they call the whole, but I'm going to call the value. So 2 is 1/3, then we need another 2 as a third, and then another 2 as a third. So this is what the whole is. I don't want to call it the 1, but this is the whole. So the whole is equal to 6. All right, let's try it again. We're going to get it. You ready? So I'm going to write it out like this. So it's 4 divided by 1/2 equals some mystery number. So going by Joey's rule, he would say that, 4 divided by 1/2. Okay, so he would say 4 divided by 1/2 is some value. So Joey said he never thought about these as division. He would say, what times 1/2 equals 4? So 4 equals 1/2 times some number. Okay, they call it the whole. It's not 1, but a whole. So 4 is 1/2 of some value. So this 4 is 1/2 of some value. So then we need 2 of them to get to the whole. So then the whole would be equal to 8. So 8 times 1/2 equals 4. It's very different. It's so different. Ready? We're going to keep trying. I always think of it, so when I look at this problem, I'm not going to lie, I stared at this for a while, and Joey's like, oh, Mom, this is easy. I'm like, oh, it is? He said, yeah, they're just thinking about it as multiplication. So 2 divided by 1/4 is some mystery number, right? So he said, don't think of it as division, think of it as multiplication. So something times 1/4 is equal to 2. So 2 equals to 1/4 times some value, which they call the whole. So it says 2 is equal to 1/4 of a whole. So this block is a fourth. That is a fourth. So to get to a half, we would need another 2. And then this would be 3/4. And this would be the whole. So what is the whole equal? 2, 4, 6, 8. All right, we'll try one more. One more. You guys got this. You ready? 5 is 1/3. Okay, so 5 is 1/3 of some whole value. So we have a whole. We have some value. This is the whole number. Okay? 5 is 1/3 of that. So we're going to divide this up into thirds. And this is what 5 is. So this would be a 5. And this would be a 5. You're going to take this whole and divide up into 1/3, and each of the thirds is equal to 5. So the whole is equal to 15. I hope that makes sense. I hope that's good. All right? It's an interesting concept, and I like it. And this is going to be like on the part 2 of the test, where if you like to choose it, you have to explain this piece down here. I just think it's an interesting way to explain division with fractions. Now there is a way that you guys were taught, and I'm going to go ahead and do the definition of fractions, like the basic old way that I was taught. And if I'll just say we're starting off with a fraction, and we're dividing it by another fraction. They called it y over z, or y over x. So to figure out the division, you keep the first fraction and multiply by the reciprocal, or the flip of the second. You guys remember doing this? So here, if we come and do this one, so 5 divided by 1/3 would be the same as 5 times 3 over 1. So that's why we were getting 15 for our answer. Now you could say, well, why don't we just teach it this way? It's so easy. But the kids don't understand it as well. Like, they don't understand why the answer is 15. They just know how to get it. But this is really nice because they understand why the answer is 15 without having to go through this weird mechanics of it. They understand visually why it's equal to 15. This just gives you an answer, but they don't understand what the 15 means. This, they really understand what the 15 means. So that's why I think it's so important that Engage New York is teaching it this way. But anyway, just to play with some of these, so just so you know the mechanics of it, or you can actually work through the mechanics of it. So 3/4 times, then you would flip that. It's called the reciprocal. And of course, we can cross these off. If you have the same number at the top as you do on them when you're multiplying, that equals 1. So that's just equal to 3/7. So this one, you'd have 3/4 times, that's technically 6/1, so if we flip it or reciprocate it, it's 1/6. So if you want, remember the quick way you can simplify these, you can break them down into their products of primes. So there's 4 and there's 6, and then the 3's cancel. So we'll have 1/8 left. And this, what a pain. So in order to divide these, you've got to first change them to improper fractions. So 2 3/8. Oh, you know what? Let me show you how to do some of these on your calculator, actually. You ready? I want to show you, if you have your calculator and you don't remember how to put improper fractions in and mixed numbers. So the n/d key is your fraction key. And then at the top, do you see the mixed number that's in green? So you have to hit the second key first. So just let me show you a couple of things on your calculator. So 2 3/8. If you enter in a mixed number and you hit enter, it will automatically change it to an improper fraction. So that's kind of cool. So you could do this pretty quickly. If you wanted to change these to improper fraction, into an improper fraction, it's really easy. You just put in your mixed number and hit enter. And of course we can do this on our calculator, but I'm going to keep the first and multiply it by the reciprocal of the second. And you can see that the 19s will cancel and you're left with 3/8. But let's just practice this with our calculator. So 2 3/8 divided by another improper or mixed number, 6 1/3. Right? So I just wanted to show you, just in case you needed a refresher on how to enter fractions in your calculator. If you have a calculator like this one, the fractions are hidden, you remember? So you have to hit the alpha y equals button, and there's your fractions. So your mixed number would be number 2, which I didn't hit. Let me try it again. So if you have a calculator like this, there's how you can enter in your mixed number. And then, hold on, one more. If you have a calculator like this, to enter in a mixed number, you just keep hitting your ABC key. So for example, if you have 2 3/8, you just keep hitting that ABC key, and if you hit enter, there it is. You see there's your 2 3/8. And then if you want to change it to an improper fraction, do you see right above the ABC key in yellow? If you hit that, that's going to change it to an improper fraction. Anyway, I just thought I'd show you how to just remember how to do some stuff on your calculators. And then the very last bit is just some paper folding techniques. This is something that some of my kids brought home, and that's why I remember it. It's kind of like the Panna Brownies, but they were folding paper instead. So I'm just going to get some scrap paper and show you, just really fast, show you what it looks like. So, well, this might be a little tricky here. I don't know. Here, I'll use this one. I'm just going to do the very first one so you can see it. So 1/2 of 1/2. So let's just pretend that this sheet of paper is my whole. So I want to start off with 1/2. So I'm just going to cut it or fold it into a half. So there's 1/2. And now it says take a half of it. So 1/2 of 1/2 is right there. Here's my answer. Here's 1/2 of 1/2. So when you open up the sheet of paper, it's kind of like the pan of brownies. You can see that the pan, or the paper's been divided up into 4 equal parts, and you chose one of them. So 1/2 of 1/2 is equal to 1/4. I don't know if you've ever seen that, but it's multiplication with paper folds. You can practice with it. It's nothing that's going to be on a test or anything, because we're not here to be able to practice it together, so it's kind of hard to see it on this. But this is something that my kids did. I remember one of them did, because I remember them making the X on the paper. So if you had 2/3 of 1/2, pretend this is my piece of paper. So you would take your paper and you would fold it into 2. So I'd be just looking at this piece right down here. Right here, I'll look at that piece. So there's 1/2, and then we would fold it again into thirds, and we'd want 2 of them. Now if you folded it, you'd have dots all along the line like that. That's what it would look like. So when you open it up, that's what it would look like. You'd say, oh, my paper's been folded up into 6 pieces, and I want 2 of them. So the kids would say the answer is 2/3 or 2/6. They don't simplify that stuff yet. Anyway, I just thought I'd show it to you, just because it's something that my kiddos did. So here, I found this online. Hold on, bear with me. You ready? Here we go. This is our celebration, because we are done. Woo! You guys did it! Happy New Year from the UK. Here, I'll hide that, because this is our celebration fireworks. I'll just let it soak in. I'm letting it soak in. Woo! You're done. That's our last video. You survived math and quarantine at home. Woohoo! All right, guys, congratulations. You did it. I'm very, very proud of you for sticking it out. You guys are doing great. Let me know if you have any questions. The review is on Blackboard. I will post the review. I've got to make the key, and I'll have that key scanned. So I'll post the review tonight, and the key will be scanned by tomorrow night, so that you guys can start getting ready for that last test. I will have times that you can pick, like I did last time. I'll send that email out probably on Thursday. It's actually on top of the review. It has the times that you can pick. So just let me know what time works for you, and if I don't see you over the weekend, because of course you can Zoom me anytime, I will see you on Tuesday in a week, but Zoom me if you have questions on the review. And don't forget that oh wow is due on Thursday by midnight. Oh no, I'm sorry, I just lied. Thursday by 12. The key's going to post at 12:30 on Thursday afternoon. Okay, so the key for that oh wow is going to post at 12:30. So make sure you get it to me by 12:30 on Thursday. Whew, you're done. All right, I will see you guys soon. Take care.